So we're in section 2.1.
Long notes for that.
Not too bad. So quadratic functions. So let's start out. A quadratic function is a special type of a polynomial function. So let's start out by talking about what we mean by a polynomial function, and then we're going to narrow it down to quadratic functions. So a polynomial function. A polynomial function, we're just going to say that it's a function that we can write f of x equals, and we're going to make it very general, so we can write it this way. So the a sub 1, a sub n, a sub n minus 1, those are just our coefficients. That's just a way of saying this is, if we have say a 5th degree polynomial, so if n equals 5, we're going to have a coefficient on the 5th power of x, we're going to have a coefficient on the 4th power of x, we're going to have a coefficient on the 1st power of x, and then we're going to have some constant.
What is dot dot dot?
Dot 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 just means whatever number we start with, we're going all the way down to a sub 0. So if we start at a sub 20 here, we would have 21 terms. So this just says we continue this pattern until we run out of.
So on that, and what is it? A plus 1 plus a sub 0?
A sub 1, yes. So that's just the coefficient on the x that has the first power. So a polynomial function is just a function that we can write this way. Let's listen up, guys. So chapter 2, we're going to be talking about functions that we can write in this form, polynomial functions. If n equals 0, that means that the highest power on x is 0. Well, any number to the 0 power is just 1. So all that we're left with is a constant. So if n equals 0, f of x is just a constant function. So that means we don't have any variables, that we just have a number. So we just have a constant. If n equals 1, so the highest power on x is 1, then we have a linear function. We just have y equals something like 3x plus 5. So if n equals 1, f of x, we say, is a linear function. And that would be, an example of that would be, like I said, f of x equals 2x plus 3. The highest power on x is 1. If we have n equals 2, that's when we have a quadratic function. So all this is saying is that we have some function. An example would be f of x. We wrote a bunch of them up on the board today. 3x squared minus 4x plus 5. That would be a quadratic function because our highest power on x, our highest n, is 2. And we have our coefficients in front of our x's. So this would be a quadratic function. So this is what we're talking about when we're talking about a quadratic function. Our general form, the general form, we talked about this briefly yesterday. The general form, and you've seen this before, we say f of x, and also remember, if when we write f of x, we can think y. F of x or y equals, f of x equals y equals ax squared plus bx plus c. So this is our standard or our general form. And for this, we're saying that a doesn't equal 0. Because if this number out front here is 0, then we don't have a quadratic function. What's the graph of a quadratic function look like? What is it? Parabola. Someone went kind of U-shaped. So anytime we have a quadratic function, our graph is going to be a parabola. And what we're going to be interested in today is if we have a quadratic function in general form, what does the graph look like? How can we figure out what the graph looks like? So questions before I change the page, and then we'll start talking about the graphs. Okay, so the graph of a quadratic function is going to be a parabola, always going to be a parabola. I'm going to sketch a quick graph of y equals x squared. If we have y equals x squared, to talk about the different parts of our graph. So let me draw a set of axes here. And my graph isn't going to be beautiful and perfect, but we just want to talk about the parts here. So y equals x squared looks something like this. This point here we call the vertex. And I'm going to do here this vertical line here, and here it's the y-axis. We call this the axis, and sometimes you hear it called the axis of symmetry. So a big part of what we're going to do today is how, given if we have a quadratic function written in general form, how do we figure out where the vertex is? How do we figure out where the axis is? Where's the axis of symmetry? Basically, what does a graph look like? Is it stretched? Is it tall? Is it skinny? Is it wide? Is it shifted? Is it up? Is it upside down? Given that formula, given that function, how do we figure that out? So the way we figure that out is we can take a quadratic function that's in general form, and we put it in vertex form. So and vertex form is going to lead us back to completing the square. So let's talk about vertex form. When we are talking about vertex form, and our book calls vertex form standard form. So I'm just going to put in parentheses our book calls vertex form standard form. I've almost 100% of the time I've heard this form talked about, I've heard it called vertex form. Our book calls it standard form for some reason, so I just want you to know that that's what they call it. If we have a quadratic function, vertex form, or what our book calls standard form, is a form that looks like this. A times x minus h squared plus k, where a doesn't equal 0, because if a equals 0, we don't have a quadratic function. So this is what we get from this is what we call the vertex form of a quadratic function. And the reason that we call this the vertex form is the graph, our vertex, is at the point HK. So if we write our quadratic function in this form, we can figure out where the vertex is right away. And the axis is the line x equals h. So when we put our quadratic function in vertex form, we can pick out where the axis is, the axis of symmetry, and we can pick out where the vertex is. How do we tell if we have our quadratic function in vertex form? How do we tell if it opens up or down? Do we remember? How do we tell if it opens up or down? Negative in front. So if A is positive, then it opens up. So I'm going to say for positive, I'm going to say A greater than 0. Our parabola opens up. And if A is negative, A is less than 0, our parabola opens down. If it were sideways, rather than writing f of x, rather than writing y equals, the x's and y's would be switched. So if the x's and y's were switched, if A is positive, it's going to open to the right, and if A is negative, it would open to the left. We're mainly going to be working with functions where we write y equals, so it's going to be opening up or down. When we get into chapter 10, we'll talk about sideways parabolas a little bit. So if we can put our quadratic function in vertex form, we can get a lot of information very easily. The other thing that we can do when we put our quadratic function in vertex form is we can figure out where our parabola crosses the x-axis. So that's going to tell us how wide it is. If we have our function written in this form, how do we tell where it crosses the x-axis? Anybody remember how we tell where a function crosses the x-axis? That's the inverse. You set something equal to 0. We set the function equal to 0. So to find where it crosses the x-axis, crosses the x-axis when the function equals 0, when a times x minus h squared plus k equals 0. Isn't that what we did for our entire homework assignment last night? Is to find where we put our functions, our quadratic equations in, we completed the square to find out where they were equal to 0. So that's kind of the connection between what we did yesterday and what we're doing today. Is to find where it crosses the x-axis, you set this equal to 0 and find the x values where the function is 0, and that's going to tell you where it crosses the x-axis. What's the other word for where our function crosses the x-axis? The x-intercept. Perfect. So cross the x-axis, 0. This is what we're going to call the x-intercept. The x-intercepts, the zeros, the solutions, we're all talking about where our function equals 0. So we have a quadratic function. If we can put it in vertex form, we can figure out where the vertex is, where the axis of symmetry is. We set our function equal to 0, figure out where it crosses the x-axis, and we have a really good idea of what our graph looks like. Any questions before we do a couple of examples using this? Okay. So let's find the vertex. We're going to find the vertex, axis, and sketch the function f of x equals x squared minus 4x minus 2. So when the problem is asking you find the vertex, the first thing you should think is we are going to put in or switch to, we want to find the vertex form. That's what this problem is asking us to do. Find the vertex form of this function. To find the vertex form, what we're going to do is complete the square. So if we have our general form, that's what we have here. To go from general form to vertex form, we complete the square. And we have to do it a little differently than we did when we were solving the equation. Here we're not solving the equation, we're switching it to vertex form. So the difference between what we did yesterday and what we're doing today is, yesterday we didn't have f of x equals, we had all this stuff equals 0. So we have to do our completing the square a little bit differently. So what I'm going to do here, when I complete the square here, is I'm just going to look at the x squared minus 4x part. And I'm going to complete the square I'm going to complete the square just on this part. So I'm not going to worry about this part right now. I'm completing the square on this part. So I'm going to write on this part, let me put a little note here, a equals 1. So we don't have to worry about the a. And b equals negative 4. Just on this part. So let's complete the square. I'm going to write f of x equals, and I'm going to put my little red parentheses to remind us where we're completing the square. X squared minus 4x. B is negative 4. Negative 4 divided by 2 is negative 2. And negative 2 squared is 4. So we're going to add 4 here. So I completed the square there. Because I don't have a 0 on this side, I'm not going to add the 4 to both sides. What I'm going to do, and this, hopefully this starts to ring some bells because I know you've done it before. What we're going to do is we add the 4 here, and then outside the parentheses, I'm going to subtract the 4. So basically I'm adding 0, so I'm not really changing anything. I add the 4 here, I subtract the 4 there, and I still have this negative 2. I added 4 here, I subtracted 4 there. So I really haven't changed anything. But now I can write this part in the parentheses as a perfect square. This equals x, and I'll break it down, and minus 4 minus 2 is minus 6. So how can I factor this part in the red parentheses? X minus 2 times x minus 2. If you can see that, if you can pick it out right away, you can say x minus 2 squared. I just wrote out the steps so we can just to show how we're breaking this into a perfect square. So this is x minus 2 squared minus 6. And now we have our quadratic function in vertex form. Now we can start to answer the question. So looking at this, where is our vertex? The vertex is at 2, -6. The axis of symmetry is the line x equals 2. And we can, yeah, Kevin. So let me scroll back here. We said our vertex form when we have x minus h squared, our vertex is positive h. So if we think back to when we did transformations of graphs, it's like it's the opposite. So subtracting inside the parentheses moved it right. So it's related to that. So now we have vertex form. We figured out our axis. We can also start to sketch a graph here. So if I go down here a little bit and I draw a set of axes, I'm going to do just a rough sketch over here. And I'm going to say my vertex is at, I'm going to go over 2 and down 6. We'll say our vertex is down here somewhere. We know our axis goes straight up from there. So our parabola is going to be symmetrical around the axis. We need to know how wide the parabola is to sketch a graph. So we need to know where it hits the x-axis. Figure out where we hits the x-axis. We just set this equal to 0. So we're going to say the intercepts x-intercepts are when x minus 2 squared minus 6 equals 0. So I'm just setting my function equals 0. So x minus 2 squared equals 6. Take the square root of both sides. So x minus 2 is plus or minus square root 6. So x equals 2 plus or minus square root 6 is where my intercepts are going to be. I can plug that into my calculator and turn that into a decimal to figure out where my parabola is going to cross the x-axis. And then I can make a nice little sketch of my parabola. And we know it opens up because our number here is positive. The number in front of our parentheses is positive. All right, any questions on what we did there to put our quadratic function into vertex form? No questions? So the parts, just to tell you where to be careful, the part that trips up most people when we're working with vertex form here is remembering that because I have f of x here, because I have y equals, I don't have a 0, I'm not adding this number to both sides. I add it and subtract it. And that's where most people make their mistakes. All right, let's look at an example where I have a number in front of the x squared, because I have to do something a little different there where I have a number in front of the x squared. If so, listen up real quick, guys. Colin asked, what if when you complete the square, your square doesn't come out perfect? If you have x minus 2 times x minus 3, if you complete the square and you come up with that, then you made a mistake. Because the purpose of completing the square is that you always end up with something that will be a perfect square. So that's a good way. If you don't end up with that, that'll tell you, okay, I've done something wrong. All right, so let's look at f of x equals negative 2x squared minus 4x plus 1. So here I have this negative 2 in front of the x squared, so I can't immediately start to complete the square. I have a little more work to do. And we want to do the same thing with this problem that we did in the last one. We're not going to worry about sketching this one. We would go about sketching it the same way. But we want to find the vertex and the axis. And when our problem asks us to find the vertex and the axis, what it's asking us to do is put it into vertex form. So the first thing that I'm going to do here when I have a number in front of the x squared is, again, I am just looking at the x squared and the x part. So I'm just going to worry about that. I'm going to factor this negative 2 out of these red parentheses. So I'm going to pull that negative 2 out. Negative 2, and I'm going to put my parentheses back here. And this is x squared. And when I factor out a negative 2 out of the negative 4, I end up with a plus 2x. And I still have this plus 1 on it. So I'm just looking at the x squared and the x part. And now I'm going to complete the square on this red parenthesis. I'm going to complete the square here. Oh, hello. So I'm going to complete the square just on this red parentheses. So in the red parentheses, a equals 1 and b equals 2. So let's complete the square. I have this negative 2. I have f of x equals negative 2 times x squared plus 2x. b is 2. b divided by 2 is 1. And 1 squared is 1. So I'm going to add 1 here in my parentheses. Now here's where we have to be really careful. This 1 is inside the parentheses. What is the negative 2 doing to the parentheses? Multiplying. It's multiplying everything in the parentheses. So I'm not just adding 1 here, I'm adding 1 times negative 2. So basically what I'm doing inside the parentheses is subtracting 2. So outside the parentheses I have to add that 2 back to make sure I don't do anything to my function. So this, I'm going to write the plus 2 because what I've got in the parentheses here is a negative 2 because this negative 2 has to distribute to this 1. So this is plus 2 plus 1. So this is where we have to be careful when we have this number in front of the x squared. Is this is multiplying the entire parentheses. Alright. So now we can write this as negative 2. Yes?
What is the 2, like the negative 2 on the outside, how do you multiply?
So what I'm doing here inside the parentheses is subtracting 2. If I multiply the 2 by the 1, I get a negative 2. So inside the parentheses I'm subtracting 2. I don't want to change anything, So to balance out that subtracting 2, I'm adding the 2 back, adding a positive 2 back, so that I end up with 0. Basically, I'm adding 0, just in a fancy way.
So plus 2.
I just put the plus 2 outside the parentheses. So those were freshmen that were touring, that are thinking of coming to Monarch that were touring. So hopefully you guys were nice. Now, what was your question, Colin? All right. So I'm completing the square just on the parentheses here, and I have this -2 multiplying these parentheses. To complete the square on this part, I'm just adding 1, but this 1 is being multiplied by -2. So I have what I really have here is -2. To undo that -2, I have to have a positive 2 out here, and that makes so I've done 0. I've changed the function by 0. Okay. Now, how do we factor x squared plus 2x plus 1 as a perfect square? X plus 1 squared plus 3. So my function is -2 times x plus 1 squared plus 3. Now we have it in vertex form. So for this one, our vertex is, for this parabola, what's our vertex? -1, 3. Our axis, x equals -1. And what else do we know about this parabola? We have a -2 here, so it's going to open down. Our vertex is going to be at -1, 3. Our axis is at -1, and it opens down. So if I make a quick sketch here, and we'll come up with this later. I'm at -1 of 3, and it opens down. Sorry, I thought it was so our parabola would look something like this. If we wanted to find these intercepts, we would set this equal to 0 and figure out where these points were on the x-axis. Have to, on some of the problems, it'll ask you to find the intercepts. It'll say find the vertex and the x-intercepts. Okay. And let's think about, if we think about moving, stretching, transforming the functions. What does the 2 out in front of the parentheses, what does that do to our parabola? Do we remember? Yes, we do remember. It makes it skinnier. It stretches it. The 2 is going to stretch it. A fraction would compress it. So the number in front of our parentheses is going to be a stretch or a compression of our parabola. All right. So those when we're putting our quadratic function into vertex form. Those 2 things that I talked about are where most students make their mistakes. Whatever we add here, we have to subtract outside the parentheses so that we end up adding 0 to our function. When I have a number in front of the x squared, I need to factor that out of my parentheses, but I have to remember that that number is multiplying whatever I add inside the parentheses, and take that into account when I take that into account outside the parentheses also, so I end up adding 0 to the function. I'm not really changing it. Right. That turned out positive because, yeah, because this turned out to be, because this was -2, so we had to add a 2. But it's not, so it might be different. If this was +2, so what's Colin asked is, are we always adding here? If this were a +2, then +2 times +1 would be 2. So I'm adding 2 to the equation. So I'd have to subtract 2 outside. I have to undo whatever I've done to it. Okay. All right, let's look at an example of another kind of problem that the homework's going to ask you to solve. All right, we want to find. All right, guys, let's stay focused. Let's stay focused. We want to find the vertex form. We want to find the vertex form of the parabola that has its vertex with its vertex at 1, -2, and it passes through the point and goes through the point 3,6. So we know the vertex of our parabola, and we know a point that it goes through. And we want to write our function in vertex form, given this information. Well, first of all, let's remember what is vertex form. I'm going to say f of x. What's vertex form for a parabola? F of x equals a x minus h squared plus k. Well, what piece of this equation do we have? The vertex is 1, -2, so that is h and k. So let's plug those in to our function. I have f of x equals a x minus h is 1 squared plus k is -2. So I can rewrite this as f of x equals a times x minus 1 squared minus 2. Yeah. Not necessarily, but we can figure out a. That's going to be our next step. What does this point 3,6 tell us? What parts of the equation are 3 and 6? Our equation goes, our function, the graph goes through this point. What part of our function are these points? What is the 3? 3 is x, and 6 is y, which is another name for f of x. So we have x and we have f of x. That's our point there. So now we can plug our point into this. I can think of f of x as y. It's the same as y. So now we're going to plug our numbers in here that the graph of our function goes through. So I have 6 equals a times x is 3. 3 minus 1 squared minus 2. And now I just need to solve for a. So 6 equals 3 minus 1 is 2. 2 squared is 4. 4a squared minus 2. Add 2 to both sides. Oh, that shouldn't be squared, sorry. I squared the 2 to get 4. So a shouldn't be squared, thank you. 4a minus 2. Add 2 to both sides. So I get 8 equals 4a, and it did turn out to be right, Kevin. So we divide by 4, and a equals 2. So my function is f of x equals 2 times x minus 1 squared minus 2. So you were saying, Kevin, I think you were saying since we're subtracting 2 here, we know that we end up having to add. Right. So this would be my function in vertex form. So when you get a problem like this, you use the numbers for your vertex and write your function in this form with h and the k, and then plug in your numbers for x and f of x, or x and y. So that's the process for doing this problem. Questions on that? Questions on that one? Scroll all the way up, yes. Okay. All right, are we good? All right, there's one other thing that I want to say for today, and then we'll be done. First, I want to start with a question. If we have a parabola, where do we find the maximum or the minimum of the parabola? If our parabola goes up, the minimum is at the vertex. If the parabola goes down, the maximum is at the vertex. So for a parabola, the minimum and maximum so for the graph of a parabola, and what gives us a parabola is a quadratic function. The minimum and minimum, I'm not going to say and or, they only have one or the other. Minimum or maximum of the quadratic function is at the vertex. So the vertex is going to tell us the minimum and maximum values. Minimum or maximum values. So that, to find the minimum or maximum value of a quadratic function, we need to find the vertex. So if your problem asks you to find the minimum or maximum value, again, you need to find the vertex of our quadratic function. And what I want to show you next is kind of a shortcut if all you have to do is find the vertex. If the problem asks you to put your function in vertex form, usually it's easier to complete the square. But if all you're trying to do is find a maximum value, there's a little shortcut you can use. So if we have, for f of x equals ax squared plus bx plus c, the vertex is at the point negative b over 2a. That's my x value. And my y value is f of negative b over 2a. So this is a shortcut for finding the vertex of a quadratic function. So let's look at a quick example of using this. So if we have f of x equals 2x squared plus 8x minus 3, and we want to find the vertex. We can use this formula. The x value is negative b, negative 8 over 2a. This is a, b, and c. So negative 8 over 2 times 2, or negative 2. So the x component, or the x coordinate of my vertex is negative 2. And the y, or f of x, the y is going to be 2 times negative 2 squared plus 8 times negative 2 minus 3. So I'm just plugging this number back into my function, and I get 2 times 4 plus minus 16 minus 3, so I get 8 minus 16 minus 3. 8 minus 16 is negative 8. Minus 3 is negative 11. So y equals negative 11, so the vertex is the point negative 2, negative 11. So just a little shortcut for finding the vertex of a quadratic function. Any questions? So hopefully this was a little bit of review. Completing the squares maybe sparked a few memories from Algebra 2. All right, homework. We're on page 116. And I strongly suggest that you try some of these problems where you're completing the square, so you can ask questions if you need to.